Hello, everyone. Mr. Minix, my name. Math is my game. I'm joined today by my favorite Algebra 2 class. Here we're talking about all, not the stain lifter, that's all, but all three forms of quadratic, I ran out of room. So not one, but two, there's three forms that I know of. And today we're going to look at all three of them. All three forms of a quadratic function or of quadratic functions. Okay. One thing that I'm guilty of is eating too many Oreos. The WFMJ today had a question on Facebook. If you were in an eating contest, what would it be? And for me, it would be Oreos, because I sit down and I eat a whole box at a time, not a row. I used to do a row, now I do a whole box at one time. Yeah, you line them up and make sure the dogs don't steal them, and yeah. So, all three forms of quadratic functions. I used to use y equals. Keep in mind that f of x and y are almost the same thing. F of x is f notation. So we saw this one. We saw y equals a times the group of x minus h, the quantity squared, plus k. We saw that one already. We've said a lot of things about that. We said with that one, that's called vertex form. That's called vertex form. The advantage of it, the nice thing about it, the thing that's terrific about it, is it makes it so easy to find the vertex, because the vertex is simply hk, the coordinates hk. And what we said about h is you really need to understand that h is the opposite of what you think it is. H is counterintuitive. Okay? H is counterintuitive. If it's a minus in there, then it's a plus and whatever. So vertex form is pretty cool. Vertex form is pretty cool. Remember that the axis of symmetry can be found by x equals h. And also, if there's a min or a max value, I'm just going to abbreviate the m value, the min or maximum value is going to be whatever the k is. The minimum or maximum value is whatever k is. Okay. So vertex form is very useful when we have to graph something, when we have to identify something's vertex, when we have to identify something's axis of symmetry, when we have to identify a minimum or maximum, right? Fair enough? Good. So that's vertex form. Well, then the other day ago, and I like saying it like that, the other day ago, we studied this other form that says y equals ax squared plus bx plus c. And this was the form that you don't want the abbreviation to. I shouldn't joke about that because it's no joke. But this is the form you don't want the abbreviation to. Okay? It's standard form. In standard form, it's easy to put into an equation editor when you have to graph it on a calculator, because you don't have to put parentheses. But other than that, it's really not nice. It's really not nice. There's only one quick thing that we get from this. Actually two, but there's really only one easy point we get. We get that the graph's going to pass through the y-intercept, which is the point 0, comma c. Okay, that's really the only nice thing about that. Because if you remember right, to find the vertex given this form, we had all those different formulas. We had h is found by negative b over 2a. And then we had two different ways of finding k. We said that k could be found by taking h and plugging it back into the original equation in place of x. And we said that there is another formula that's not in your book that I showed you, because I want you to be equipped with as many of these tools as necessary. And there's another formula to find k, and I always make that a look like a 9. Sorry about that. So there's that. Okay. So those are two of the three forms. Okay. We've seen those. We saw a vertex form in chapter 4, section 1. We saw a standard form in chapter 4, section 2. And vertex form, pretty easy to deal with. Standard form, when you have to find the vertex, it's a nightmare. It's not a nightmare, but it required some work. Now, before I show you the third form, I want to try a brain trick. It works 80% of the time. Works 80% of the time. There's nothing behind the number that I'm picking, but I'm picking the number 6. Okay? I like the number 3, but I'm picking the number 6. Now, don't freak out on me here. I'm just writing numbers on the board. Okay? There's nothing behind this. So I'm writing numbers on the board, and I just want to focus on these numbers, and I'd like you to focus on these numbers. And if you know this, don't give it away. But I just want you to focus on them for about, I don't know, 15 seconds or 20 seconds. Just focus on them, read them. Study the numbers. Take a deep breath. Inhale. Exhale. Quick, think of a vegetable. Don't tell me what it is. Think of a vegetable. Don't tell me what it is. Somebody got one? If this worked, you would have thought of a carrot. Now, if you didn't think of a carrot, maybe you said pepper. Okay, so that was purely for entertainment. That's not related to the lesson. I just thought I'd do something fun there. So, okay. If you did think of a carrot, don't ask me. Well, I do know why it works, but I don't have time to talk about that. So here's this new form. This new form, I'm not going to give it a name yet. We're going to explore it on the calculator. We're going to explore it on this calculator. I like exploring things. So I want to add a graph page, and I want to look at, bless you, x minus 2 times x minus 3. So notice what the equation is. It's x minus 2 and x minus 3. And I'm going to write that up. So y equals x minus 2 and x minus 3. Do we think we know if this graph's going to open up or down? We're thinking it's going to open up. Why do we think that? Because the parentheses are opposites? Not necessarily because of that, but we're onto something. It is going to open up for sure. It is going to open up. Check it out. Look what it looks like. Now, I'm going to use my zoom feature. I'm going to zoom in. I'm going to do a zoom box, actually, right around those points. So what I want to do now is I want to use my special set of eyes. And these things are called zeros, which I'm calculating. Okay, I'm calculating zeros. And this equation has a 0 at 2 and a 3. Interesting. So it goes to the point 20 and the point 30. Before we go any further, I want to define something so everybody has this definition. By definition, a y-intercept, I could define it 15 different ways, but I'm going to say a y-intercept is the value of y when x equals 0. A y-intercept is the value of y when x equals 0. Now, if we back up for a minute, and I know people hate when I go forward and back in the lesson, but if we look at something like y equals negative 6x squared plus 2x minus 17, some people remember that the c is the y-intercept, and some people remember that this thing's going to go through the point 0, negative 17. Other people need to replace x with 0, so they'll say y equals negative 6 times 0 squared plus 2 times 0 minus 17. So sometimes people need to simplify this. 0 squared 0, so that's negative 6 times 0, 2 times 0, 0 minus 17. So that's negative 6 times 0, 0, and 0 plus 0 minus 17 is minus 17. Some people need to work through all that. But anyway, the point is the y-intercept is the value of y when x equals 0. Does everybody get that? Okay. And this last graph that we just looked at has 2 points, 2, 0, and 3, 0. Anybody know what those 2 points are called? The what? The x, why'd you say they're the x-intercepts? Because it crosses the x-axis, and also because it's the values of x when y equals 0. So what these things here are called, these are x-intercepts. Okay, those are x-intercepts. Those are x-intercepts. So when we saw an equation, a function, I'm sorry, when we saw a quadratic function in vertex form, something like 3 times x plus 7 squared minus 10, when we saw something in vertex form, we could quickly identify the vertex as negative 7, negative 10, right? When we could quickly identify the vertex, it's probably in vertex form. When we can quickly identify x-intercepts, what do you think that form is going to be called? You would think it's called x-intercept form, and you're almost right. They just got lazy and left the x out. They just call it intercept form. Okay, so intercept form, here it is. Intercept form. Intercept form. Not interest form. Not interest form, it's intercept. There we go. Intercept form. F of x or y equals a times the group of x minus p times the group x minus q. Hey, wait a minute. Didn't we see a in standard form? Didn't we see a in vertex form? And the other day ago I said a is a. Do you think this is the same A? You think it does all the same things? It is, it does. If A is positive, the graph opens up. If A is 2, it's a stretch by a factor of 2. If A is 1, the graph is shaped identically to the parent function. What do we think? Making a little bit of sense? So, P and Q are the, what do you think P and Q are? P and Q are the, yeah, they're the x-intercepts. Good. They're the x-intercepts. P and Q are the x-intercepts. P and Q, like H, are what? How are they similar to H? What do we say about H? H is the x-coordinate of the vertex. Now, these aren't going to be the x-coordinate of the vertex necessarily, but they're like H in some way. Because they're a letter in the alphabet. Because they're a consonant. Because they're not a vowel. Because they're lowercase. Because they're short for something else. Like H is short for Henry. And P is short for Paul. Maybe Pam. And H could be short for Henrietta or Harriet. Somebody help me out here. P and Q, like H, are the opposite of what you think they are. How do I say that? With one hyphenated word. Thank you. They're counterintuitive. They're counterintuitive. They're counterintuitive. Okay? P and Q, just like H, are counterintuitive. Now, we're going to come back to this in a minute because we still got to figure out how to find the vertex, because when we graph, well, that's where we start with the vertex. So let's back that thing up for a minute. Let's go to a new problem. And let's add another graph. This time I'm going to add -2 times the group of x plus 7 times the group of x minus 6. Is this graph going to open up or down? I'm hearing up, I'm hearing down. Which way? It's going to open down. Remember, A is A. So here we're graphing y equals -2 times a group of x plus 7 times a group of x minus 6. So we don't know exactly what the graph's going to look like, but we do know, we said it's going to open down, right? And if it's a stretch by a factor of 2, it's going to be a little bit narrower than the parent function. So it's going to do that, but we don't know where. We have no idea where it's going to be located, do we? Could we ballpark it? Let's think about our x-intercepts. Our x-intercepts are p and q. What would p be? Now keep in mind that we're going to get p when we drink a lot of Gatorade, or when we look at that first binomial, that first thing in the parentheses. That's where p is going to come from. You think it's 7. You would think it's 7, but it's the opposite of what you think. It's going to be -7. So what's that? It's my x-intercept, which means it's where the graph goes through the x-axis. So the graph of this thing is going to go through the x-axis at -7. 1, 2, 3, 4, 5, 6. Way over here is where it's going to go through the x-axis. So maybe the graph, maybe the graph's going to look like, maybe it's going to look like that. No, because it's also got a q. It's also got a q, and let me get my purple marker. I like purple. It's got a q, and the q is a result of the, get my highlighter going. The q is a result of looking at this binomial. What's my q going to be? The q is going to be 6. 1, 2, 3, 4, 5, 6. So there's my q. So the graph's got to go through both of those points. So maybe I should flip this thing around. Maybe it's going to look like that instead. No, we know what A is. We know that A tells us the graph's going to open down. So maybe what the graph really does, let me move this out of the way for a minute, see if I can get all this shaken up. So maybe, here's the x-axis, I forgot to take that. So maybe the graph really kind of looks like that, huh? That's probably more what it looks like. So what are we expecting the maximum value of this thing to be? High, something huge, something big, probably bigger than 10, maybe bigger than 20. Maybe it's going to be 84, maybe, just a hunch. How far in between P and Q, how far in between P and Q do you reckon the axis of symmetry is going to be? How far between P and Q do we think the axis of symmetry is going to be? Let me get a vertical line going. My axis of symmetry is a vertical line that bisects the parabola. How far between P and Q do we expect the axis of symmetry to be? Right over here, maybe? -1/2? Well, how are you getting that? How far in between these two is it? There's a total of 13. So it's 7 this way, 6 this way, but it's got to be, are you saying it's in the middle? Oh, yeah. Yeah, because of symmetry. Because of symmetry, the axis of symmetry is in the middle of P and Q, right? What's another way to find a number in the middle? What's that called? The mean, right? Or the median. How do you, what's another name, an A word that means the same thing as the mean? The average, right? Do you remember the midpoint formula from geometry? Oh, no, not that. Oh, no, not that. Let's back this up for a second. I think we're on to something. H, which is the x-coordinate of the vertex, is halfway between, or it's the average of P and Q. If we want to average something, what do? We add them up, and we divide by how many there are. Well, we have 2 of them. So we divide by 2. Ta-da! Yay! We could probably have figured that out without even knowing the formula. Ha! Oh, but we got to find the other coordinate of the vertex too. Oh, no. Well, there's a real easy way to get the other coordinate of the vertex. Remember what we did when we had the standard form? What did we do? Anybody have a Glade air freshener? What's Glade air fresheners? How do they work? You know those ones that you insert into the wall socket? What are they called? Glade what? Plugins. We plug them in, right? Plug it in, plug it in. So it's going to be A times X minus H. No, not X minus H. A times H minus P times H minus Q. In other words, we're just going to plug H back into the original equation in place of X. I smell something in our future for Algebra 2. My advanced Algebra 2 class, they already did this. I don't like that sniffing sound. It's annoying. Sound like a rabbit. I smell foiling on the horizon. Oh no, foiling. Okay. So let's work with this problem we're still working with. Let's see if we can't find H. H is going to be P plus Q over 2, so it's going to be negative 7 plus 6 over 2, so that's going to be negative 1 over 2, and that's okay. Fractions happen, right? Fractions are a part of life. So that tells me that my axis of symmetry for this graph, is going to be where x equals negative a hizzy. That's a half if you don't speak that language. We had that 10 minutes ago. So how in the world, or where in the world is Carmen Sandiego? How in the world do we find K? K, we're going to go back to the original equation, negative 2 times something. Times what? Times x. I'm going to replace x with h. All these stupid fractions. All these stupid fractions. All these stupid fractions. I was actually wrong about the max value, by the way. I'm sorry. It's going to be close to what I said it was. It's going to be a little less, but what did I say, 84? Oh, no. Look at this. Would you just look at it? Would you just look at it? We got to find K, and we got to deal with these fractions. Oh, man. No. Better bust out the calculator. No. We didn't spend a week of fractions for nothing. Negative 2 times. Now 7. Isn't 7 really the same thing as 14 halves? So I have negative a half plus 14 halves, so that's going to give me 13 halves. And I know I just lost half the class. Oh, where'd you get the 7? Where'd you get 14 halves from? I just multiplied 7 by 2 over 2. Don't freak out. We did that last week, okay? Don't freak out. You're not lost. You're not an idiot. You know what we're talking about. I'm going to turn 6 into halves. I'm going to multiply 6 by 2 halves. So that's going to be negative a half, take away 12 halves. That's going to be negative 13 halves over there. Now, one thing to notice here, and it's going to happen every single time. Do you see this 13 halves and this negative 13 halves? If you're doing this right, if you found h the right way, if you made the proper subtractions and additions, these two quantities here, when you get to this point, will always be opposites. They'll always be opposites every time if you're doing this right. Now this 2 out front is really over 1. Can I maybe cross cancel that 2 out front with something? I could cross cancel this 2 out front with this 2 down here, so I have negative 13 times negative 13. Negative 13 times negative 13. I hope you know your perfect squares. If not, my advanced Algebra 2 class, their quizzes on that's coming. Algebra 2, yours is coming in the future. So negative times a negative is a positive. It's going to be 169. And then in the denominator, I got 1 times 1 times 2. That's going to be 2. So 169 divided by 2 is 84. I was close. No, it's more than 84. 80. Yeah, it's 84 and a half, right? 84 and a half. 84 and a half. Oh my gosh. 84 and a half. Dude, that's crazy. That's crazy. So my vertex is way up there at negative a half, 84 and a half. Now I know what you're thinking. You're thinking, dude, there's no way. Well, let's look. Hey, there's the rainbow array of fruit flavors. I'm going to use my special eyes here on this. My zeros, there's 1 0. Surprise, surprise. -7 is my 1x intercept. I'm using my special eyes again. My other 0 is at 6 0. Surprise, surprise. Now I need to see a point that's way up higher than I could see, right? I'm going to do what? Zoom. What kind of zoom should I use? Zoom out. I hit zoom out and nothing happened. I got to click somewhere. Where do I want to zoom out from? Maybe up here toward the top. Not enough. Let's do it again. Not enough. Let's do it again. There we go. Now I need to turn that off, and I'm going to hit escape to turn that feature off. So now I want to menu analyze. I want to find my maximum, and my maximum, which is my vertex, is at negative a half, 84 and a half. Wow. Well, what the heck was that 84 I was thinking about? What the heck is the 84 I was thinking about? Anybody know? We found the x-intercepts. We found the vertex. What else? What other points of interest are there to find? The axis of symmetry we found too, but we're on to something. There's really only one other thing it could be, where the graph crosses the y-axis. It's the y-intercept. It's a y-intercept. So I guess what I'm kind of getting at is this. We had y equals -2 times x plus 7 times x minus 6. Let's see if we can't do this. Let's see if we can't put this into standard form. Put into standard form. Oh, I'm dreaming up a really cool quiz for next week sometime. Maybe even a 25-point question on a chapter test. Take this function and write it in all 3 forms and compare and contrast all 3 forms. Can you compare and contrast 3 forms? Or has it got to be 2 to compare and contrast? So what is it if you're comparing 3 things? That we might have to look that up. So let's put this in standard form. Oh my goodness, I feel like Annie from Annie. Y equals -2 times x plus 7 times x minus 6. I've talked about cake in here before, right? Or maybe I haven't. I told you I like Oreos. I like cake too, and I like to eat cake. But there's only one way to eat cake. Everybody eats cake the wrong way. My wife, she scrapes off the frosting, eats 1/4 of the cake, and then throws it away. But before she does, she at least asks me, do I want the frosting? Sometimes I do, sometimes I don't. But there's really only one way to eat cake. I'm going to sketch a piece of cake for you, if that's all right. Hopefully this doesn't offend anyone. It's going to have white frosting on it, okay? Is that fair enough? So there's my piece of cake. There's my chocolatey filling. Everybody got the idea? When you eat cake, what you do is you turn the piece of cake on its side. Like this. Maybe even upside down. And you scoop out this part and you eat that. So that's first. You eat that. And then you break it apart. And then you scoop out that part and you eat that. You eat the cake first. And then you do the frosting. I'm just being silly. What I'm getting at is everybody loves a distributive property and everybody's anxious to distribute this too. Don't distribute the 2 first. You can, but it's just going to make life so much harder for you. Okay? Save the 2 till the end. Trust me on this one. Okay? Forget the 2's ever there. Forget about it. So we're going to go ahead and multiply this out with the technique that Mr. Massey knows. I love calling Mr. Massey on the phone. I'm like, Mr. Massey, how do you do X, Y, Z? He says, FOIL method. FOIL method. I wish I had speakerphone. I'd put him on speakerphone and he'd say that. So here we go. We're going to take the first 2 terms of this these binomials, and we're going to multiply them. And this is where the f, whoa, I just dropped part of my marker, and it's crazy. And it changed the color of the screen. Imagine that. Maybe it's because of the f on the board. What the f just happened? What happens when we multiply the x times x? What do we get? X times x is x to the squared, right? The second part of FOILing is the O part. And a lot of people have a misconception about it. It's not zero, it's the outer terms. The outer terms, we find their product. Remember, we're multiplying here. X times negative 6. X times negative 6 is, isn't that negative 6x? So we get negative 6x. Negative 6x. Now, if you're in my advanced class, you're probably going to want to run through this in fast forward. I'm going to use mint green. Mint green. The I part of FOIL means you take the inner terms, the terms that are on the insides that are toward the middle, and you multiply them. 7 times x, 7x. And then finally the L, not to be confused with the L train, formerly known as LeBron James. Take this 7 and this negative 6, and you multiply the last terms. The product of 7 and negative 6 is 7 times negative 6, isn't that negative 42? Negative 42. How's everybody doing so far? Good. Okay, Houston, we have some terms. We have these two terms here in the middle that are like. They have the same exponent, the same variable. What can we do with like terms? We combine them. So our x squared is still our x squared. Negative 6x plus 7x is going to be 1x, right? Instead of writing plus 1x, I'm just going to write plus x. Is everybody okay with that? So plus x, and then minus 42 is minus 42. Doing all right? Okay. Now, I told some of my classes about my friend Gary. Did I tell you all about Gary? Anybody have a friend that goes over to your house and hits on your sister or your brother, steals all your chocolate and eats it? I don't know if any of you smoke yet. If you do, don't. It's bad. I quit 6 years ago. I'll talk to you about it if you ever want to know how I quit. But anyway, my friend Gary would smoke all my cigarettes when we partied. When we were a little bit older, he would show up at a party and drink everybody else's beverages and not bring any. And whenever we went anywhere, he never gave anybody gas money, never paid for dinner, and he just went along for the ride. So anyway, the point here is that the negative 2 is kind of like Gary. This negative 2 that's hanging out front, it's just going along for the ride. Until one day, Gary decides to pay for dinner and be a nice stand-up kind of guy, like he should. So don't forget about that negative 2. This is the icing on the cake, right? Because we all love the distributive property. We're really good at it. So now we distribute the negative 2 through. So this is going to be negative 2x squared, and then what? Minus 2x, and then what? Plus 84, right? So that's how we would transformers. That's how we would transform that equation into a standard form, right? Now, our y-intercept should be 0.84. So maybe let's go to the graph and see if this, well, let's go to the table. The table, does this thing go through 0.84? It sure does. 0.84. Okay. Now, I don't want that table there, so I'm going to undo that table. I want this window to look a little bit different, if you don't mind. So I'm going to do a zoom fit. I'm going to do a zoom fit. And I don't like that. Now I'm going to do a zoom box. I said I'm going to do a zoom box. Maybe I should have just set my own window settings. This is going to do it. There we go. Is everybody fair? Is that fair that that's a nice picture of the graph? Okay, so what I'm going to do is I'm going to add a second function. I'm going to add a different function. I'm going to add negative 2x to the square minus 2x plus 84. What do you think the graph of this second function is going to be? I'm hearing the same thing, right? It should be. Check it out. Boom. It's the same thing. I'm going to add a third function. The third function I'm going to add is going to be negative 2 times the quantity of x. Now, what was the x coordinate of our vertex? It was negative a half, right? So what am I going to put in the parentheses? Not negative a half. Plus a half. Good. Plus a half. I got to put the squared. And then plus 84 and a half, right? What do you think that graph's going to look like? There you go. What do we think? All three forms of the same function, they look identical. So let's think about this. What are some advantages of standard form? We get the y-intercept fast. We can see A clearly now that the rain is gone. What are some advantages of vertex form? We can quickly find the vertex if we're graphing it by hand. What are some advantages of intercept form? We can quickly find the x-intercepts. How are we feeling about this? Okay? So at this point, I'd like to show you a function like this. Y equals x squared minus 5x plus 6. And I want to show you if you can apply all the concepts that we're going to study in Chapter 4 quickly, how fast you can graph this. I don't have any tricks up my sleeve. I don't have a graphing calculator inside my brain. But I'm going to break this function down one piece at a time. So I'm going to graph that point, 0, 6. Meow. I'm going to say that this function is going to go through the point 2, 0 and 3, 0. And you're probably thinking, dude, how did you get that? I'll show you. Check it out. My advanced class right now has factored, and they know that this factors into x minus 2 and x minus 3. So they would have found those x-intercepts just like that. So now I know my axis of symmetry. I said my axis of symmetry is halfway between those. My axis of symmetry is halfway between those. And I know since my A value is 1, I could go over 1 and up 1. But that's not really going to help. Oh, man. But I do know what my H is. I do know that my H is 5 halves. So now if I wanted to find my K, I would take 5 halves minus 4 halves. Where'd 4 halves come from? I don't understand that. I rewrote 2. Okay, I multiplied 2 by 2 halves. That's where this 4 halves came from, if you don't get that. And then I'm going to have 5 halves minus what? Minus. Is that going to be 6 halves? So I'm going to have 1 half times negative. Hey, look at that. Those are opposites. Oh, they're opposites. That's what they're supposed to be. So this is negative a fourth. So there's my vertex. There's my vertex at wherever it is. At 5 halves, negative 1/4. And there's my graph. There's my graph. That's the way. I like it. Do we need a graphing calculator to graph this? No. And you're thinking, dude, this is way too much. I don't get it. Well, the factoring part, my advanced class is already doing that. We're going to get to factoring in 3 weeks. Mr. Jones is going to be teaching the Algebra 2 classes how to factor, and he's going to do a great job with it. I know he is. Does anyone have any questions, comments, concerns, short debates, long debates about any of the 3 forms? Well, I forgot something from all 3 of them that somebody should have called me out on. What did I forget to mention in all 3 forms of quadratic functions? The maximum and the minimum, I didn't say anything about that, but it's not the end of the world. But thank you for noticing. I didn't say anything about the max and the min. You're right. All the stuff about A kind of, I think, addresses that. But there's something that I neglected to leave out about these quadratic functions. Something that if I don't mention, that they're no longer quadratic functions. Let's see who remembers for 4.1 homework. A can't equal 0. For all of these, A is not allowed to equal 0. A is not allowed to equal 0. All 3 forms, A is not allowed to equal 0. If A equals 0, then we don't have a quadratic anymore. One more thing, and then that's it. Final thing. Remember I told you my Algebra 2 class, you're going to have a quiz on Friday. My Algebra 2A class next week, we're going to be solving equations by factoring, and we'll tie some things together. But you're going to have to find the vertex of something like this. Could we find the vertex of something like that? Some people like algorithms, step-by-step procedures. First step, what's the first step to find P and Q here? Or, I gave it away. What's the first step to find H here? Identify P and Q. Identify P and Q. Okay, so what are P and Q? P is 4 and Q is -2. So then the second step to finding the vertex would be to find H. So how do we do that? Plug into the formula, P plus Q over 2. So 4 plus -2 over 2. So that's 2 over 2. So that's 1. I'm halfway home to my vertex. Even if you don't know how to do anything else, you could write off to the side, here's my vertex. I tell you what, true story, tomorrow's quiz, Algebra 2. You're taking the quiz. You write that the vertex is these 2 points. I'll give you 3 out of 5 points just for writing this. Just because I'm feeling pretty fly today. Step 3, find K. How do I find K? I plug back in. K is going to be 2 times X, but I'm replacing X with the 1. 1 minus 4. 1 plus 2. So what do I get? I get 2 times something times something. Hey, look, the parentheses stuff are opposites. They're supposed to be. If they're not, you did something wrong and you probably found H wrong. So that's going to be -18, huh? Don't forget to write your vertex as an ordered pair. So my vertex then, but wouldn't it be a shame to have done all that work and not write the numbers in the parentheses? So my vertex is 1, -18. We're going to be all right with that one. There's going to be at least one of those, maybe 2 on the quiz. One more thing, a pitfall to look for. I've shown it to you all week long. I'm going to show it to you one more time. Check this out. Y equals 8x minus 2x squared. Find the vertex. First of all, it's not in standard form. Second of all, it's not in vertex form. Third of all, it's not in intercept form. It's not in any of the forms. It's close to being in standard form. But here's what people are going to do on this. They're going to say H is negative B over 2A. And so they're going to say, so it's -2. You're already wrong. You're already wrong. Aren't you? Because in standard form, this is y equals -2x squared plus 8x. Almost forgot the x. Hashtag don't forget the x. So h is -8 over 2 times -2. So that's -8 over -4, so that's 2. So my vertex here is going to be 2 something. 2 squared is 4. 4 times -2 is -8. I hope it, hold on a minute. 2 squared is 4. 4 times -2 is -8. 8 times 2 is 16. 16 minus 8, I think it's 8, right? Yeah. Did I mess something up? Why did I switch the equation? Great question. Why did I switch this? Because this is my bx term. In standard form, that's my bx term. And over here, this is my ax squared term. And standard form says we put the ax squared term first. Okay, terrific question. Thank you for asking. Okay. How am I feeling? Doing all right? Questions, comments, concerns, short debates? So you're going to have, my Algebra 2s, you're going to have 5 minutes to take that. My Algebra 2As, they're taking a quiz tomorrow. It's going to cover all 3 sections, and they're going to struggle to finish in time. So it's been real. It's been fun. I hope everybody has a good, long weekend. I'll see you later.